All right, graphing. Graphing and understanding graphs. So you may have seen this before in your math class, just rehashing it and showing you in terms of physics. Okay, so we have here a y-axis and we have here an x-axis. Along the y-axis you'll always see distance or velocity or maybe sometimes acceleration. On the x-axis you'll always see time. Okay, time. All right? So when we say draw a velocity versus time graph or a distance versus time graph, always remember that distance and velocity are always on the y-axis and time is always on the x-axis. Okay? That is what that means. Something versus something, that is always y versus x. Okay? So that's always what that means universally. What does the slope of a distance versus time graph represent? So looking at this, okay, there are three different lines here. There is a black line representing a straight horizontal line. There is a green line that is going up from 0 up to some point. There is a red line going from 60 down to the 0 on the y-axis. So this is 0 on the y-axis. This is 0 on the x-axis, okay? What is happening with those three lines? Well, they're reacting differently. Let's only pay attention first to distance, okay? Paying attention to distance only first, let's see that we see that after 1 unit of time passes, we are up to 10 meters, okay? 10 meters. I didn't draw the M for meters, but all these represent meters, okay? After 1 second, we've passed 10 meters. After 2 seconds, we've passed 20 meters, okay? So our distance is changing with every passing of the unit of time. We say that with respect to time, okay? And finally, at 50 meters, we've come to 5 seconds, or other way around. Once we've reached 5 seconds, we've reached 50 meters, okay? And if you were to say, well, how fast are you going at that moment? How fast are you going? You can say, well, take our distance we've covered, 50 meters, and we say divide it by the unit of time that has passed. Okay? Divided by the unit of time that has passed is 5 seconds. 50 divided by 5, well, that's just 10 meters per second. Okay? 10 meters per second. That's how fast we're going with respect to time. Or, I'm sorry, that's just how fast we're going. So, the other way, so what does the slope represent? What does the slope of the graph represent on a distance versus time graph? The slope represents speed, okay, speed, unless you know what direction you're going. In that case, it represents velocity, okay? So, unless you know what direction you're going, then it represents velocity. What does the slope of a velocity versus time graph represent? Okay, so if the slope of a distance versus time graph represents velocity, then the slope of a velocity versus time graph would generally represent, you guessed it, acceleration. Good job. So it's acceleration. And First of all, let's see what's happening with each one of these lines. So our distance decreases from 60 down to 0, from 60 to 0, over a passing of time. Would you say we were getting faster or slower? Very right, we're going slower. Okay? Our velocity is decreasing down to 0. Okay? Down to 0. What about this green one? We go from 0 up to some value of unknown quantity. I've just kind of stopped drawing it there. So our distance is increasing as our time increases. Nothing decreases in that. So what's happening there? We're actually going faster. Our velocity is increasing. Okay. Our distance is increasing with respect to time. So our velocity is going positive. Okay. So, but what about this black line? Are we moving? Are we moving with our distance versus time graph? Are we going anywhere? No, we're not. As time passes, we are staying at the same exact spot the entire time. Okay, so our velocity slope is 0. Okay, that is a 0 slope going straight across, horizontal line. Okay, so now let's get rid of distance and just pay attention with velocity. Velocity. So as your velocity increases, you are accelerating. All right, we're accelerating. Okay. If you're just driving 70 meters per second in a straight line, we are not accelerating. Our acceleration is 0. Our velocity is not 0. We can be moving and have a 0 acceleration. Okay? We can be moving and have a 0 acceleration. Here, our velocity decreases from 60 down to 0. So we are decelerating. Our acceleration is dropping, okay, down to 0. So that is, and we could also change this. We can say this is no longer distance. We can say that it is now velocity. And if that's the case, we would put this meters per second. Put a second right there. Okay? All right. That is acceleration and velocity, that's just graphs. That is graphs. Thank you very much, and look forward to the next video.